Hi guys, this is Faizan and welcome to this session on competitive programming for beginners by Great Learning. So before we start, can you guys quickly give me a confirmation in the chat section if you guys can hear me properly? Is there any echo that is there any noise or I can see hi. So yeah, is there any noise that you are hearing or any echo so that we can rectify it right now right here? So please guys quickly, and in the meanwhile Great Learning has come up with an initiative. We all know about it, right? The Great Learning Academy initiative, wherein we have 100 plus courses available for free for limited amount of time. So yeah, you guys can check them as well. And okay, great. Yes, there is. Okay, great. So you guys can hear me. Yeah, cool. So now before we start, can you guys quickly write? Yeah, it will go. Just give it 5 minutes. So yeah, great. So now before we start, can you guys quickly give me a confirmation that have you guys started coding in these platforms, Lead Code, Geeks for Geeks, HackerRank, HackerEarth, or anything like Code Forces? Are you doing that quickly? Can you give me a confirmation on that? Which platform are you using for your programming? Aman, quickly. Mukta, Umesh, Afrin, can you guys quickly give me a confirmation on that? Which platform are you using so that I can help you with that? How to solve problems on that? How to start doing problems? HackerRank. Okay, Aman. Great. So any more? Mukta, I'm saying which platform you are using for your programming, competitive programming. Not the language, not Java or Python. Language can be anything. Code Forces, okay, great. HackerRank, okay. CodeChef, great guys, great. So, Geeks for Geeks, okay, cool. So, in my opinion, if you ask me where do I program or which platform do I use Lead Code, right? So basically in Lead Code you have a very good set of problems, and therein if you get stuck, okay, so if you get stuck somewhere, there is always a solution over it, okay. At some there's a tab for solutions. You can just check or go through them, right? So it helps you to build something, do a dry run, use printf statements, right? So it will help you to gain some now how do you start with easy problems, right? Right now I'm going to tell you how these levels are defined, okay. Okay, great guys. So these levels, how are these levels defined? Okay, so basically you have easy set of problems, right? Okay, Dexterous. So you have easy set of problems, you have medium and hard. So basically what is a medium? Basically you will be using for example, if you used a program to find the minimum, right, or threesome problem is there, right, in Lead Code, the first problem that you see. So now these easy problems, when we club them together, two easy problems, when we club them together, then it will make a medium level problem, okay. Both the concepts will be used in medium. And how you will what is the hard problem or hard level problem? Basically two medium level problems or three medium level problems, right? So basically now what I want you to do, guys, so start doing easy level problems, okay. Now don't get stuck over easy level problems. If you are facing any problem, go see the solution, okay. Don't waste time, don't exhaust maybe 3 hours doing some easy level problem for medium. And if you are just starting doing it, maybe for now you can exhaust 1 hour, but not more than that, okay. Go see a solution and start doing, okay. Now this is all about Lead Code. Now if you're doing Code Forces, right, so therein we have the problems with the name A, right? There is the alphabet A with them. So these are easy level problems, right? We have a watermelon problem right there in the Code Forces, right? So basically that problem is nothing but you have to do you have to find even and odd numbers, right? So basically start doing that. And on HackerRank and Geeks for Geeks, they are much more easier as compared to Lead Code and Code Forces. So preferably if you guys are now, this is the fifth part, right? So if you guys are comfortable right now doing some problems, yeah, you will be able to do some problems, right? So start doing it on Lead Code. Geeks for Geeks is much more, there is no, if I am using Geeks for Geeks, you see in therein we have problems which are repetitive, okay. it doesn't make any sense to do same problem over and over. Okay, just go into lead code or code forces. Maybe start with lead code, that you can jump over what to code forces. Okay, code forces, there's a that the UI UX of the user friendliness of code forces is much more difficult as compared to lead code. Okay, now let's get started with the session. Okay, now I think we have all the guys here. Okay, cool. So now today let's see the sir, can I use GL certificate with our resume or for job opportunity? Absolutely, absolutely, Umesh. Just you need to if you are adding something in your resume, you should justify it, right? So if you are adding something, then maybe if I will ask you questions on that, you should be able to answer them. Okay, I have enrolled for part 6. Great, Nidar. So what, after this session is over, go through all the parts, right? This is the 5th part, right? Right, this is a series, right? It will go up to maybe 10, 20, 30 depending upon how you guys respond. Okay, so like the channel, subscribe to our channel. Okay, so after that you will just if you have any problems or if you are not able to understand anything, write in the comments. Okay, if you are not able to, okay, if I'm not able to answer them in the heat of the moment, or maybe sometimes I skip some questions, not intentionally but yeah, maybe sometimes it happens. Okay, so you guys can then comment on the once this file or this video gets uploaded, at that time you can just comment and we will get back to the answers. Okay, maybe someone somewhere someone is watching this and he will answer those questions. There is a huge great guys. Now let's get started. Okay, now let's see the first problem. This is a medium level problem, and after this you will see, okay, why this is a medium level problem once we will complete this. Okay, now let's see the first question. Find the repeated number in an array. So you have been given an array. Okay, in this array, let's suppose the length of this array is 7, right? I am new, can you introduce yourself? Maybe later in the course, yes. So right now just focus on what we are trying to understand here. Okay, yeah, how to improve recursion. We will get back to that, Aman. We will also see a series. We will also start doing some questions based on recursion. Okay, after that there will be no such problem. Okay, great. So now this is the question, right? Find the repeated number in an array. Okay, so if you have the length of this array is 7, right? So the numbers in this array will be from from 0 or from 1 to n, including the n. For example, if this the size of this array is 7, right? So there will be only numbers which will be from 0 to 7. Okay, great. So if you see the repeated number is 5 and only one number will be repeated. Can you repeat this? Okay, so basically this question is about find the repeated number, and there will be, it is the question, the constraints of the questions. I haven't written it here, but the constraints are that the numbers will the range of numbers that will be present in this array will be from 0 to n. That means 1, 2, 3, 4, 5, 6, 7, including the 7, but not greater than that. And only one number in this array will be repeated. It can be repeated multiple times. Okay, can you perform XOR? No, we cannot. Okay, we will see why we can't perform XOR. Okay, so basically if you perform XOR, so it will give you only zeros for what? If for 5 and 5, right? So it won't work. You try it out. So now in the second second case that I have put, the input is 1, 2, 5, 4, 1. So if you see, 1 is repeated twice. Now can you give me any any intuitive approach or any naive approach for solving this problem? XOR cannot be used. Come on guys, I'm waiting for your answers. Just an intuitive approach, how you will solve this problem. We can use dictionary. Okay, hash map. Okay, good. But you don't have to, if you think about it, we will get into that dictionary as well, or hash map, what you called in Java, or hash sets. So hash map will have a value and a pair, right? So are you using the value, is there any significance? Sort it and then check. Okay, use for loop and break in Python. Okay, great. Now let's see the first approach, right? So the first approach will take what? N log n time, right? You guys have, some of the guys have told, right? They have just said n log n time complexity. Great, Afrin. So now if you sort this, and then what you will check, I'm starting, that's brute force, right Thakur? So that this is a brute force algorithm, right? So if you see, I'm starting from 1 and up to the length of the array, and then I'm incrementing. So I'm starting from 1, so I'm checking the previous element, right? If I sort this array, what will be the sorted manner of the second input? Okay, 1 1 2 4 5 6. So I'm checking, I'm starting from index 1, so I'm checking previous index. Okay, is this, yeah, Mohit, yeah, right, you're right, absolutely right. So now if you see, if you check the previous element, right, so I will check if they are equal, so I will return that element, and if I am exhausting this for loop, after that I will return -1, saying that there is no such number. Okay, no such number exists. Okay, this is quite fairly simple. The space complexity is constant and the time complexity is n log n, right? So this is one approach. Now most of you said hash maps, hash sets, right? So now we will use another approach, that is hash set. So we know what a hash set is, right guys? It will always keep the entries in the hash set will be always unique, right? So if there is something, now we can use this property, right? Now what I did here, I just traversed through the elements, right, of the array, and one by one I inserted them in the hash set. Okay, now I know if there is a entry which is already present in the hash set, it will throw me an, I mean to say, it will just return the true statement, right? Okay, this element exists already in the hash set. Okay, then I will know what this is, a element that is repeated. Arvind says XOR. So Arvind, the property of XOR is that there are two properties of XOR, right? Why we use or when we use. The first one is that the XOR of 0, right? If there is an element 0 and there is an element 1, so the XOR of 1 and 0 is 1, right? And if the both elements are same, then it will result me in 0. Now if you do a XOR of all the elements in this array, only you will be able to get what, 5. And I'm not saying that it is repeated only twice. It may be thrice, it may be 4 times, it may be all the elements are the same elements, right? 3 3 3 3 3, right? So that doesn't make any sense. You will get a 0 output, right? So if you do XOR XOR XOR, maybe it's 6 times, then you will get 0, right? So your answer is wrong, right? We need to get 3 as the output, right? We need 3 as the output, right? So XOR cannot be used. AND operation can be used, sir. Okay, if you're using AND, let's suppose you are using AND. So and the property of AND is that if both the digits or both the bits are, yeah, Arvind got it, great. So if both the bits are 1, then only you will get the result as 1. So now you need to do some bit manipulation here, and when you implement it, even if when you do that AND operation, you won't be getting the right result. Okay, now this is the second approach. Now during the interview you did this thing, right, and the interviewer was smart enough to tell you, right, so I don't want this approach, can you give me something better, right? Or I don't want you to use the space complexity that you are using, right? I'm using a hash set which stores the elements, right? In the worst case, it will store all the elements, right? For example, 1 2 3 4 5, and all the elements are present in the hash set without any repetition. So in worst case, the space complexity is n, right? And if we talk about time complexity, right, so we are traversing each element once, so for n elements we are traversing n times, right? 1 2 3 4 up to n, so the time complexity is n. Now can we do better? The question is, can we do better? Any guesses or anything that you can do to remove this space complexity? One of the guys told that you can use rabbit or what, that tortoise and turtle thing, right? Rabbit and turtle approach. So now let's see how we can reduce this space complexity. Okay, now there is an algorithm called Floyd algorithm. Okay, this Floyd algorithm is used for cycle detection. Now if you see, this is the diagram that I want you guys to remember it or understand it carefully. Okay, this is the base of many questions, right? If you talk about cycle detection in strings, in arrays, right, or in linked list, right, this thing can be used. This algorithm is called Floyd algorithm, and with that Floyd algorithm there are 2 pointers, right? Therein we have 2 pointers. One is fast and one is slow, or one is called a rabbit, that moves fast as compared to turtle, right? The turtle moves slowly. So the intuition behind this problem is, I will tell you once I will go through this algorithm and we will see its implementation, then I will give you an overview why does this work. Okay, just stay with me. Great. So now there's a thing called slow pointer and fast pointer. Now slow pointer will move one. There's a one. The step it takes is one, and for fast it will take two steps. Right. So you feel me, right? You are there, right? Guys, you can understand until and for how much we have covered. You understood each and everything, right? Just give me a confirmation quickly because I don't see any questions or anything. Yes, just give me a yes, no, maybe quickly, guys. This is very important, Floyd algorithm for cycle detection. It will solve many problems, right? So quickly give me a confirmation if you guys can see, if you guys can understand. Yes, no, maybe. Okay, Afrin says yes. Great. So now let's start. Okay, Arvind, great. So the intuition behind is that if you see slow pointer is moving, the slow is represented by S, and then each step I am representing it with S1, S2. The each step, right? You see, once it will move, it will become S becomes S1. So it's the first jump. Okay. So now let's start. Okay. If any of you have any confusion, stop me right there so that I can explain you again. Okay. This is very important, guys. Okay. So now slow moves from the first node to second node. Both the slow and fast pointers are present in the first position. Okay, these are nodes, let's suppose. Now, slow moves to this S, the pointer that is S, representing S, slow moves here. And fast moves F, the fast is here. Okay, let me just show you it in a different manner. Okay, now let's see. So let me remove these things, okay. Let's remove these things. I will show you how to do it and you will get an intuition. That's all I need. I need you guys to understand this carefully. Okay, this will make the base of a lot of problems. Okay, just a minute, guys. So great, now let's start. So both the pointers will be here, right, on this start when the thing starts, right, when the loop starts, both the pointers will be here. Now S comes here, right. So S comes here to this location. Okay, now F comes here, the fast pointer. Now the next step is that fast moves again and slow moves again. So first we will move the slow pointer to here and this will remove it. We will remove this and fast will move two jumps, right. First it was on this S location and now where will it be? It will be here somewhere. Okay, the fast pointer will be here. Okay, the first jump will be here and the second jump will be here. Okay, guys, cool. Now let's see how this thing works. Okay, now S will move here on this location and F will move here, two jumps, right. F will move here. Okay, you are not able to see this. Okay, right. So F will move here. Now again we will move S will move here and again F will move to this location. Okay, we are still moving, right. Unless and until they will meet, we will not be able to justify that this is there's a loop in this thing. Okay, so now what happens, again we will move our slow pointer to this location, right, here, and then the two jumps for F will be here. Okay, right. So two jumps, right, from here to here. Now S will move again and we will be somewhere here, right, guys. S will be here. Now when fast moves, fast will be also here. Now when this slow and fast pointer will meet, we can easily detect, or this is the first phase, right. In this phase what we will do, if they meet at some point, that means there is a cycle. Okay, now how do we remove this cycle? Basically we will do nothing. We will just move one of the pointers, maybe slow or fast, and what we will do, we will start again from the starting. Now start, F will move, F will remain there and S will start again from the starting point, starting node. Okay, guys, now what we will do, we will just move one by one them. This is the second phase of this problem. Okay, one by one. So F will move one step, again, and then S will move again, S will be here, and this F will move again, and S will be here, right? Now, the next time when they meet, this is the meeting, this is the condition that we will be able to find that, okay, this is the node that is forming a loop. As I told you earlier, right, there will be only one element that is repeated, okay? It can be repeated multiple number of times, but there will be only single element. So this is the thing, okay? Now this is the whole algorithm, okay? Now we will see the base conditions. You don't worry, Vidya, okay? We will see the base conditions. Now you got the intuition, right? Afrin, Vidya, Nidhiraj, Linu, Abhishek. You got the point, right? So why we are using and how does this work, right, guys? Are we doing any round robin algorithm, sir? Round robin not here. Why F is not skipping one circle? So that's the main objective here, right? The Floyd algorithms works in such a manner that if we are moving, let's suppose that you have to reach the distance is X, and now you are moving twice and your friend is moving what? Single time, right? He's moving one step, you are moving two steps. So, okay, great. So that's why the algorithm, why we are doing this, we will see. But the intuition here is that we have a slow pointer and a fast pointer, right? They are moving, both of them are moving, but fast is moving two steps and slow is moving one step. So now, once they will meet, we will be able to find that in the first phase, right, that there's a cycle. And then we will start the slow and fast again from the first point, right? And then we will iterate one by one. And once they will meet, we will be able to find, okay, here is the point that we are having cycle. And this is the answer. Okay, now this is the whole intuition of this algorithm. Okay, guys? Guys, just quickly give me a confirmation. Okay, cool. So now let's go back to this thing. Okay, now you see. Now, one thing that you guys didn't observe carefully is that once they will meet, okay, got the problem solving with mathematical logic isn't, it's okay, what it problem solving with mathematical logic isn't, yes, it is something that is related to mathematics. Okay, now what happens, if you guys have observed, there will be always this case, right, that once these two pointers meet, and just quickly give me answer this question first. Will this be the case always that you will be having, once you rotate this cycle, that in the first rotation you will get your answers for both, either the slow pointer or for the fast pointer? No, right? So there will be sometimes this, will be a case for this case, right? For this thing, for this this diagram that I have shown, there is this, I mean to say, there is this thing, right? Okay. So now there is this thing happening that this is we are able to meet only once, right? For the slow pointer, it is happening that slow and fast meet, or the slow pointer has only traversed this loop once, but fast has traveled two times, right? So now after they meet, this will always be the case that the distance that slow and fast, once they will travel one by one, they will meet at the position where there is a loop. This will always be the case. And now why it will be the case, we will see. Okay, we may not need to set the boolean flag. Okay, now let's see how does this work. Okay, now if you see, now this is something that we do when we are playing around with linked list. Now let's suppose that this is our array. Okay, 2, 5, 9, 6. These are the array elements. Okay, now if you observe carefully, are they in the same manner, right? Are they in the same manner that I have written the array elements and this loop diagram that I have shown, the links between them? Are they same? Is the order of them same? We may need to write a recursive function. So no. So Vidya, no recursive function, because if you're using recursion, then again you will be using the space complexity, right? There will be again a space complexity of n, or maybe less than n, but there will be some space complexity. That is not the objective here. Okay, we are trying to reduce the space complexity. Okay, now if you observe carefully, guys, the array elements and the loop that I have shown the diagram here, are they in the same? uh, Vidya, binary search. Yes, you can apply binary search, but right now we are dealing. I will show you that example also when we talk about binary search. We will again pick this example. Okay. So our friend says no. Yeah, great. So these are not in the same manner. Now, if you observe this problem or if you see this problem, right, that I haven't written these array elements, right? Naveen Commerce. No problem, Naveen. If you are interested in competitive programming, just pick pick a language, maybe Java or something, in which you feel that you will be comfortable working with. So you can just start with it, and we have courses available, right? I have myself taught Java, and there is a Hindi course also available in Java. You just go through that course. It is only for 1 hour, to say for 2-3 hours. You will get the basic idea. Then you can start with this competitive series. Okay, Naveen? So now, no, they are not in the same order. Now, how will we get this thing? Okay, now you see here, if you do the same thing, you will be able to find 9. Okay, now write the diagram somewhere and start iterating through it. Okay, for slow and fast, both of them will be at 2. Right, guys? Now let's iterate. Both of them will start at 2. Now slow will be at 9, fast will be at 1. Okay, fast will be at 3, slow will be at 1. Fast will be at 8 and slow will be at 5. Fast will be at 9 and slow will be at 3. Again, second time, this fast pointer will loop around this link, rotate around this loop. Okay, now it was earlier at 9. Now, now Nidhi, there is no problem if you are using Python. Okay, you can implement this same. Right, now 9, fast was at 9, it will move at 5. Now again our slow was at 3, right? Now it will move at 6. Now fast is at 5 and slow is at 6. Now again when we do a single jump, it will be at 8. Both of them will meet at 8. Now if you observe carefully, now we are iterating, the fast pointer is iterating twice, right, guys? So basically it is iterating one and a half times. Okay, and the slow is moving only once, and it hasn't completed the single rotation also. It has something around 75% of it has completed only once, not even once, right? So how many iterations are expected? So this thing will work, this thing will work in order of n time. Okay, Vidya? So just focus on this question. Okay, this will form a base of many questions. Okay, the tortoise method, is it? Yes. Now both of them will meet at 8. Okay, now if we move both of them one by one, okay, now it will become it will be somewhere around at 2. The fast will be here. Now we will move them one by one, and then finally what we will get that the 9 is the meeting point. Can you explain the question? So the question is nothing, that we are dealing with Floyd algorithm, that is the tortoise and the hare thing. Okay, this is the algorithm that we are dealing right now, and we are just seeing the intuition behind the problem, right? This slow pointer and the fast pointer thing. Once they will meet, and then we will start again. Okay, great. So now if you observe, right, guys, you observe this thing that they are not in the same order. Now how will we do something with this array elements so that we can get this kind of a structure? Okay, guys, now let's see that. So the space complexity is, obviously we are not using any extra memory, right, guys? So the space complexity will be 1. That was the main intuition, right? To reduce our space complexity. Now I told you guys, right? So do not focus on slow and fast, how I was able to move these pointers. So question is, find duplicate in array. Yes, there are many versions of this question. I will try to cover all of them. Rest is up to you. Okay, great. So if there is multiple duplicates, then we will see that also. Okay, Mohit, we will see. That's the objective here. I'm trying to build something upon something, building blocks, right? So that's what competitive programming is all about. This is a medium level problem. Now why it is a medium level problem, you can easily do with the help of sorting or with the help of hash set, right? We saw that. But this was something that was asked in Amazon. So yeah, does it make sense now why people don't crack these exams? If you don't know, you cannot solve this problem. Okay, so got it? Now if you don't know this algorithm, it is 50-50 chance, maybe ratio of 20-80 that you will get selected, or you will be able to qualify that round. And after that there will be many rounds as well, but to to qualify, you need to qualify all the rounds, right? So this was something that was asked in Amazon, and this is a medium level problem. Okay, now after this I will show you another problem that was also asked in Amazon and Oracle. Okay, now let's see. Just a minute, guys. Okay, yeah, now let's see. Can we try using bubble sort? Okay, if you try to use bubble sort algorithm with here, what will be the time complexity of that? Order of n square, worst case, right? So we are dealing with something that is of order n time. Does it make sense with here? Yeah, cool. So now what we are doing, forget about this, how I am moving around and how I am changing the array elements. Forget about this for now. Now what I am doing, if you see the first phase, that is the do while loop, right? So both of them will be at the start will be at what? At the first element, right? That 2. If you see, both of them will start from 2. So that's what I'm doing. Slow is at 2 and fast is at 2. Done. Forget about these two lines which are present in do. We will come back to this. Now, unless and until slow is equal to fast, right? Once they will meet. So let's suppose the meeting point is M. Okay. So once they will meet, what happens? I will just break out of this loop. Done? Right, done, guys? So now once I will break out, this is the first phase I was talking about. Okay. Unless and until that you will find the meeting point. Okay. Please repeat, sir, your explanation at the end. At the end where? Okay, I will repeat this. No, don't worry. So now you know that I am starting both these pointers from 2. That is what I'm doing. Slow is equal to num0 and fast is equal to at num0. That is the, okay, it's written nums. Okay, let's, this is the array element. Okay, that 2. Okay, so the 2. Now, I am looping around, right? I told you, unless and until you will find a point where both of these will meet, you will not stop. Okay, that's how we will detect that there is a loop. Okay, Naveen Kumar, I was late. No problem, Naveen. Just focus on what I'm trying to say here. Okay, cool. So once they will meet, I will just break out of the loop. For example, the meeting point is here. Let's talk about here. The meeting point is M. Okay. Now once I will find this meeting point, then what I will do, I'm just moving one by one, and unless and until they will meet, that is the loop, right? Okay, so now what I did, I will just start the slow pointer from AR of 0. That's what I did, right? I told you I will start one of the pointers, either the fast or the slow, from the starting again, right? That's what I was doing, right? You see here when I showed you that diagram, right, guys? So what is nums array? Basically, it's array. Okay, I have just removed this. It is ARR. Okay, it's ARR of 0. Their nums is nothing. Okay, cool, guys. There's a misprint. Okay, guys, so now what happens, I will just start iterating one by one. You see, slow is moving 1 time and fast is moving 1 time. Once they will meet, I will be able to find this point, that is 9. Okay, guys, is the intuition clear? Now let's talk about, this is the whole thing that I was talking about. Now if you see, if you try to dry run it, okay, use take out your always, whenever you are attending my session, always keep a pen and paper in front of you, because I want you guys to understand something that is more over of a mapping kind of a thing. Okay, trying to connect the dots, so that you will not able to understand unless and until you will use or you will write anything. Okay, guys, quickly. Manish Giri, what is nums array? Manish, is it clear? Sir, can we write nums in place of array? Obviously, that's just the name. You just have to remove the argument that starts from ARR. You just write their nums, and then the rest of the code, instead of using ARR, you just use nums. Okay. So here I have written nums. It should be ARR of 0, and fast it should be again ARR of 0. Okay. Can you answer my question? Nidhi Raj, what is your question? Come again. Nidhi Raj. Okay, quickly, guys. You have. If there are multiple duplicates, is that your question? Okay, I didn't see your question, Nidhi. Okay, Suvarna. Okay, great. So now what is happening? We are doing the same thing, right? The logic that earlier I explained. Now take out your pen and paper and start iterating through it. Now if you see, what is the question I just joined? Manish, the question is, we are trying to find the duplicate in the array with the help of Floyd's algorithm, that is the tortoise and the hare thing, okay, or the turtle and the rabbit. Okay. So now if you see, slow was at 2 and fast is also at 2. Okay. Now what happens? Now how I'm iterating and how I'm building this structure. Okay. Naveen says sorry. Why you are sorry, Naveen? Okay. So now if you see how to join the meeting in how to join the meeting. So you are talking about these live sessions, right? Okay, Naveen, you can just, I mean to say, you can just revisit this lecture once it is uploaded. And if you haven't seen any previous ones, you can just go through them as well. Okay. So now if you see, both of the slow and the fast are at 2. Okay. Now what I am doing here, now how I am iterating, if you see ARR of slow, what is slow? Slow is 2. Now ARR of 2, what is that? If you see ARR of 2 is 9. So the next jump will be at 9. So this is how I'm building it. Okay guys. Everyone is late today. So now if you see, okay guys, if you see how I'm building this thing, okay. So if you see 2, right, 2, ARR of 2, what is ARR of 2? 9. So this is how I'm building this, that slow pointer will move from 2 to 9. And what about the fast pointer? That is ARR of 2, that is again what? ARR of 2 is 9. Now ARR of 9. I will get back to that question, Nitin. We are just starting this, so just wait. I will complete that if you have multiple duplicates as well in this same session. Okay, just be with me. Okay. So now what I'm doing here. Okay. So now ARR of 9. That is the ARR of 9 is what? This 9 elements. This one element, right? The last index. So this is how I'm building this. Okay, I joined fix at 9. So yeah, the timing, the meeting start, the live session starts from 9. We have the community posts as well, wherein you can check the timings. Okay, for all the live sessions, not only this, for all the live sessions. Okay, and also you can again always register, right? So you can also do that. Okay, so now what happens? So if you see, if you observe carefully how I'm looping around this, okay, how I'm building that, how this 2 moves to 9, this is a slow pointer, and how this 2 moves to 1, the fast pointer, okay, this is how you do it in arrays. Now if you talk about something that is linked list, right, so at that time you just have to iterate 2 times, right? Let's suppose the linked list name is node, right? Nodes next, and then the next of node dot next, okay, that's how you do it in linked list. But in arrays, that's how you do it. Okay, array slow, that is 2. Okay, great. Okay, where is Abhishek? Abhishek, did you get this? Everyone, did you get this intuition that how I changed my array into something like this structure? Okay, and then how I did this thing. Okay, is it clear, guys? Is it clear, guys? Quickly, yes, no, maybe. How I did this thing, how I iterated from this. What is we get array index out of bound exception while trying array or fast? So Manish, to answer your question, so there will be always, the fast pointer will always be in that range, because we are trying to build something that is looping around. So you will never get an array index out of bound. Try to figure this image in your head. Okay, try to put this image in your head and then figure, is there any case that you will get array index out of bound? Say Puram says no. Okay, you didn't get this thing. Okay, did you okay, let's just rephrase this thing, everything. Okay, now if you see this image that is present on your screen, how I built this is clear that this is the thing that we are trying to build. Now how we will build this thing? With the help of these arrays slow. Array dot slow, and then what happens? Array, that is the array index, and the index is fast. So array of fast. So array of fast at starting, what is fast? Fast is 2. So array of 2 is what? Array of 2 is, if you see the array, not the image. If you see array of 2 is what? 9. And what is the array of 9? It is 1. So you see now if we jump from 2 to 1, that is what is fast pointer doing, right? You see the image. Try to connect this image with the code. Okay. So rather the code drawing with your presentation speaks a lot. Yes, we are working on that, Vidya. We will see if somewhere right now I don't have that graphic tab. So if I'm getting that graphic tab, I will just start coding in such a manner. Okay. I think this is a C language code. So it is kind of a language independent code right now that I have written here. So you can do it anyways. Okay. So if you can implement this thing in Java. I'm just writing the function. Okay, guys. There's nothing else. I'm just writing the functions. It is language independent. Sir, please write the index there, sir. Where? Okay, on that thing. Okay. Okay, now let's see. So now guys, try to understand this, okay? And try to think over it. So why I'm doing this? Try to figure this image with this array and then see if this code satisfies this problem, okay? I don't think C is publication. Okay, now let's see. This approach is clear. Now, why does this Floyd algorithm work? Okay, now see the why. Let's cover the why part. Now we know how to do it. Now let's cover the why part. So if you see, let's suppose the distance from of the first 3 nodes, the point where they meet again in the second phase is x, and the position from where they met at first time, right, in the first phase, that is m, and that distance is y. And the distance once we started again in the second phase, one by one we covered them, right? So that distance is z. The total length of the loop, that is this loop that is shown on your screen, is L, which is nothing but y plus z, right? And now the meeting point is nothing but x plus y. That is it, right, guys? This is the image. This image speaks for itself, right, guys? So this is a Java code that I have written, okay? It is Java, yes. So you can implement it any language, right, guys? There is no specific bound to where. So rather use. I will suggest that you either use Java or C++. Okay, great. Now let's see. Yes, Vidya. So now if you see. Now this image is right, this image speaks for itself, guys, right? So you have this distance x, then the y distance, and then the meeting point is x plus y, and z, the distance that we travel one by one. Now let's see why does this work. Okay, now if you see, what is the distance traveled by fast pointer? Okay, if you see, the fast pointer traveled x distance, then the y distance, and right, if you see this thing, observe this, the distance traveled by fast pointer, it was x, and the looping, that the loop it will traverse, it can be multiple times, right, guys? There is no specific thing that it will traverse only one time, right? This n represents the number of rotations. This can be either 1 or 2 or 3, totally depends on the question. Clear, sir? Now great. So now if you see, this n represents the number of rotations, and now this y is the last distance that is traveled in the second phase, right, guys? Okay, so now what happens? What happens here? So if you observe carefully, what is this distance that is traveled by y pointer? Okay, now let's see that. If you observe this carefully, the distance traveled will be again what? X, then the y distance, and then the z part. Okay, this is the distance traveled by both these slow and fast pointers. Okay, now what happens? I know this thing, right, for sure, that distance traveled by fast pointer and distance traveled by slow pointer will be twice, right? So that's why what I have written, right? The distance traveled by fast is 2 times the distance traveled by slow pointer. Now when I substitute these values, I will get, I have not written the whole thing, but I have just, it boils down to this thing that x plus y is L times, right, the number of times the iteration, the rotations, the loop thing, right, the length of the loop into n minus 2m, which is nothing but the integral. So it means that something, if 4 is the length of the, that means the number of nodes are 4 or 5 or 6, right? In this case there are 6, right? That multiplied by some integer. Okay, now if you multiply something by that, it boils down to this thing, right? How would you come up with this approach on a fly in an actual interview in such a short time if you haven't solved it? Yeah, that's the thing, Manish. That is the thing. That is, you have to practice a lot. These things come with practice. You can do hash set or all those things, the sorting things, but these things, unless and until you will not be able to, if you have no idea regarding this, you won't be able to solve this. Okay, maybe if the interviewer is good enough to give you some hints and you are able to catch them, so that he will do. Okay, he will explicitly ask you, do you know Floyd algorithms, how it works? So let me give you an idea how Floyd algorithm works. Okay, right? So now it boils down to something that is the integral part, right? So the length of the practice yes Abhishek. So now it boils down to this thing that x plus y is equal to L into some integer, right? So now what happens, this thing is nothing, if I say you in a naive way, that this thing means that if you start again when the meeting point, that always this thing happens, that once they will meet, the distance traveled from right, I traverse one by one, then from m, right, this z portion I traverse, and when you traverse this x portion, right, so they will always meet to that that particular portion where there is a loop. Okay, this all boils down to this thing. So if you have any can you case study discrete mathematics in yes. So if you have, now if you want to do a research on this thing, do a research. I just gave you the whole idea, right? I mean to say, briefly I explained you that this is the thing, how it works. Okay, so now let's jump to the next question. This was also asked in Amazon and Oracle. Okay, now you have to find the first repeated element, not the last, or not the I mean to say, not the first. If you see, which is the first element that is repeated, is it 2? 2 is repeated, but before that 5 is repeated, right? So the output should be 5, right, Vidya? Okay, now if you see the second example, 16, 2, 54, 16. So 16 is the first repeated element. Okay, this was asked in Amazon and Oracle. Okay, now again this is a medium level problem. Now we will see how to do it. If you see intuitively, you will use 2 nested loops, right? You will get your answer, but the time complexity of that is order of n square, and the space complexity will be constant. Now can we do better? Obviously we can, right? So we will use hash set. Now it was written in the question that space complexity is order of n, that will be expected, right? If you see the Geeks for Geeks, that's why I didn't suggest you guys that Geeks for Geeks, rather go with the lead code. Okay, so now what is your assignment? Try to solve this question in order of 1 time, right? The space complexity is 1. I don't know if you can, but give it a try. Okay, do some research. Okay, now if you see, we use hash set here, right? So we traverse from the backwards, not from the starting point, right? Not from this 2, we traverse from 7. Okay, so that we will put all the elements, and at the last, when we get the element that is repeated, that we will store that element which is present at the first index. That's what we did here. Okay, we placed all the elements in the hash set, right, guys? Now what happened, this index I is at the starting, it is at -1. Okay, now what happens, I traverse from the length of the array -1. Obviously the indexing starts from, if the length of the array is 7, then the indexing will start from 6. So that's what I'm starting from 6, and I will traverse unless and until I reach the 0th index, right, the first element. Okay, now what I did, I traverse backwards, right? That's the thing that I did here, right? That's why the iterator I is decrementing. Now what I did, I checked if that element is already present in the array, then I store the index of that. Okay, then I will return the index. Okay, that's the main thing. I stored the index of that is I, and if that is not present, I stored the element in that in that set. So if you traverse backwards, you will always be able to get the first repeating. Okay, not the second, not the third, but the first repeating elements. Okay, first repeated element. Now this is the simplest approach, and this was asked in Amazon. Obviously there will be some tricks to it. Okay, there will be something that geeks for geeks might have skipped, right? Obviously this seems simpler, right? So you have just used a hash set and that's done. Maybe at the face-to-face interview or in the next round he might have asked him the same question over it. Okay, now try to reduce the space complexity, right? Try to do that, figure it out. Okay, in the next session, if you are not able to get that, we'll see if we can do it or not. Okay, cool. Now the question that most of you started asking: what if there are multiple duplicates? Right now, not the one, not the two. There are multiple duplicates. If you see in the array that is given 2, 5, 4, 2, 4, 1, 6, right? So 2 is repeated twice and 4 is repeated twice. Now you have to find all the duplicates in the array. Again, this is a medium level problem, right? So there are multiple approaches, almost 5 to 6 approaches, but all of them are what? Naive approaches. Okay, now try to figure it out. Okay, just give me some intuition over it, how you can do it. This is something that is, I mean to say, you will use it a lot of times. Okay, what is a hash set? Basically, yes, hash set is nothing. If you had heard about what a hash set does, let me tell you about the properties of the hash set. Okay, will there be any session on DP? Yes, Manish, there will be. There will be a session on DP, backtracking, recursion, greedy, all of them. Okay, so hash set, how hash set works basically, if you have elements, so let's suppose 1, 2, 3, 4, 5. The property of hash set is that it always stores a unique element. Okay, if you try to store multiple, I mean to say the frequency of those elements are more than once. Okay, and you want to store them. Okay, at that time you will use hash map. If you want to store the frequency, how many times this element has occurred. Okay, so at that time you will use hash map. Now what is a hash set? Basically, I will talk about the properties, then you can figure it out. Okay, so the first property is that it will always contain unique elements. Now the second and most important, or there are many properties, but the most important property is that in order to insert an element, okay, or to find an element in that hash set, right, this contains method, this add method, right, these all methods take a time complexity that is constant. So that's why we use hash set most importantly, and this is the most overly used data structure in competitive programming. Okay, Yash? So this is the thing that why we will use this thing. This contains dot method, right? This dot contains method will always find the element in constant amount of time. You do the maths, right? You do the maths that how it does, right? If you observe it carefully, you see that internally it uses hash map. Okay. Okay, guys. So now let's see the output of this. Please make tutorials in Hindi. Okay, Munir, we will work upon that. Okay. So now let's see the approach, and this is the most not the intuitive but the most efficient. Okay, and the space complexity and time complexity is written on your screen, that is order of n and order of 1. So now the function that is written on your screen is that we are using the intuition that if the element is present twice, okay, if the element is present twice. So for example, let's suppose there is 2. Okay, now there is 2, right, guys? So now what I'm doing, I'm iterating. Okay, so I'm iterating once. Okay, now I'm iterating from 0 to length of the array, right, guys? So now I'm at first element. Now I will check. I will just do the, what does this ABS do? This is nothing that I'm calculating the absolute value. So because I'm using the concept that is that if a number, I multiplied a number by -1. Sir, I don't understand. For another thing. Sir, I don't understand. What is the problem that you're facing, Aman? Please tell me. So what I'm trying to build here, that if a number is multiplied by -1, that will represent that this number has already occurred. Okay, this is the intuition. Okay, that's why I used the absolute value sign. Okay, so to calculate the original value. Okay, obviously. So now that's the thing. If the number is present once, then it will be something. It will be. I will not change the element. I will just, it will remain the same. Okay, it will remain positive. Now if it comes twice, then this number will be multiplied by -1, so that I will detect, okay, this number has already occurred, and that's what I'm doing here. That's it. Okay, now let's see the dry run. Let's try to dry run it. Okay, now if you see the element, that is the first element, that was 2, right? So the 2 is the first element, right? I will check the absolute value. The absolute value of 2 is 2 itself, right? Now I check the element that is present at index 2. So ARR of 2, that is what? ARR of 2, if you see 0, 1, 2, that is 4. Okay, Now I checked. If this 4 is greater than 0, yes, because it hasn't come, right? If something is multiplied by negative, that is always less than 0. So obviously it is greater than 0. Now what I did, I just multiplied this 4 by minus 1. That's it. Okay. Now once I multiplied this number by minus 1, it will be minus 4. So the output will be 2, 5 minus 4, 2, 4, 1, 6. So multiplying by minus 1. Smart approach. Okay. Okay. So now what I'm doing here, again I will iterate. Now this time the iterator is at 1. Okay. So 5 has been picked. Again, this is a non-negative number, right? So I will find what is the element that is present at 5, the index 5. Okay. So you will check 0, 1, 2, 3, 4, 5. So it is 1. Okay. Now again 1 is greater than 0, right? So again it will, I will be able to find out that this is the number that is not repeated. Okay. You have to do a lot of dry run, guys. I mean to say, I cannot explain you this thing in something. I'm just giving you an intuition, guys. Unless and until you will start dry running it, you won't be able to. This is something that if you studied right now, after 2-3 days it will go away. You have to make notes, you have to think over it, try to dry run it, so that next time if you face such a problem, okay, you will be able to figure out, okay, at that time I used something that is multiplied by minus 1 and I was able to find that thing. Okay, right? So you have to use this thing. Basically this is all related to count sort. If someone has idea of some count sort, how we use the frequencies, right? How we find out the counting, that if the number is the frequency type, right? Now that at that time we use the count array and then keep incrementing it. That is something that the same intuition is used. Okay, this will come with practice. You don't have to worry about this right now. Okay, just be with me and let's try to dry run it again. So now 5 comes and I check the 5 element, I multiplied with minus 1. So now the array elements will be 2, 5 for minus 4, 2, 4, minus 1 and 6. Okay, can we do stack again? Okay, so again, if you do stack, the space complexity will be, Vidya, will it be order of 1? No, it won't be order of 1, right? The stack will use the number of elements that you inserted maybe at some point. So it will be what? Again, you are using space complexity big O of n. So instead of, if you are using stack, you can use a hash set, right? So why have such a, I mean to say, why you will use stack? That is unnecessary. If you want to use an extra memory, try to use a hash set, right? And insert all the elements. Wherever you are not able to insert, you will find out, okay, this is the element that is repeated for all the elements, right? That's what we did earlier in this case, right? That is shown on the screen. The hash set that we used. That's the thing, right? So now we have to find all the duplicates, but with a constant space. Okay. So instead of 5, if array of 15 will throw an array. So it will never happen. Manish tried to run it on several examples. Okay. This is the case. Why this does not happen? Because array elements will always be in such a manner that if you have n, the length of the array is 7. Try to think, Manish. So you are again and again asking the same thing. So if you have an array length of 7, there will be always the number present in that array will be always in the array elements. Okay, so always the array elements present in that array will be in a range from 0 to 7. So if something is between the range, would you ever find something that is 15 or anything? Well, that will be the case. No, because all the elements will be in such a manner that it will range from 0 to n. Right? That's the constraint. So that's why we are able to use this thing. Got it, Manish? So you check this question, okay? So you go through all the constraints, okay? Maybe on Lead Code or on Geeks or Geeks, okay? So now that's the thing. Sorry. So now array 7 come. Okay, yeah. Cool, Vidya. Cool. So now knowing how array 7 comes. Array 7. 1, 2, 3. Array 7 is nothing, it is n written, that is the length. Okay, I didn't know there was a restriction provided in this question that it will range from 0 to n. Yes. So that's why it will never happen that you will get an array index out of bound. Okay, So now if somehow the element we found that is less than 0, okay, that is the minus sign, obviously we know that okay, this is the element that is repeated, print that element. And will we use the minus one that is repeated? No, obviously we will do the absolute value of that in order to get the actual element. So that's what we are doing. Try to dry run this, guys. So I will again suggest you guys watch this video twice, thrice, and then try to dry run. Okay, unless and until you will not use pen and paper, you won't be able to go anywhere. Okay, this is the thing about competitive programming. You have to, even if you are not getting any now what I want you to guys to do, okay, now you have learned, I mean to say you have attended 5 lectures. If anyone hasn't, go through all the lectures and now start coding. I want you guys to start coding on lead code, not HackerRank or not Geeks for Geeks, not Code Forces. Start coding and start from easy level. Try to filter that most liked questions, and or more top 100 interview questions. There's a filter in that. Okay, start doing the easy problems first. Okay, and then try to not do not get overexcited and try to solve as many as easy problems as you can. No, you have to keep thinking and try to utilize as much time you can. Why? Because this thing will happen. This thing will help you. GFG explanation are a bit confusing sometimes. Yes, exactly. So Manish, I want each and every one of you, whoever is attending this session, try to solve questions, easy level questions for this week till we meet on Sunday, okay, or Saturday. I try to solve as many questions. I will ask each one of you how many easy questions. Don't go to the hard. Start, register yourself, log in, and then start coding. Solve the easy questions, and I will ask each one of you that how many questions did you solve. Okay, sounds good. And try to implement these things. How many the things that I have taught you. Okay, so that you get some confidence. That's all about. You get confidence, so that confidence is half the victory. Okay, that's what we do. That's how we learn. Okay. So you have to be confident, okay, I will do this. Maybe not in 30 minutes, maybe in 1 hour, okay? So you have to do it. Manish, Abhishek, Leenu. Okay? Great guys. So this is all about today's session. In the next session, I wanted you guys to have something, heaps and hashing. But for hashing, I have to first cover hash set. Now in the next, we will use hash map. And then we will try to solve some hard problems, okay? In which way we will use hash map, hash sets and heaps. Heaps are more important, very important, and the most important algorithms or data structures that you will be using while solving these questions on lead code is hash set and hash maps. Trust me on that. I have myself used million of times, but I will also tell you that don't overuse it. Okay, don't try to overuse hash sets and hash maps. Try to think of a better solution without using time complexity, not the space complexity. Okay, hash sets. Okay guys, thank you so much guys. So always like, share, okay, and subscribe to our channel so that I will also know that you guys are interested in more competitive programming parts or series. Okay, so also once this thing is uploaded, okay, this video is uploaded, also if you have any problems or if you want me to do something for the beginners, obviously we will start from the scratch, that's why. So you can't go, okay sir, teach us DP in the next session, because rest of the students will fall down. Okay, so try to think of what are the array algorithms that you are facing problems in, or stacks or queues or hash maps, hash sets. Try to comment them. I will absolutely do that thing, and we will work on that. Maybe in the next session we can pick some of the questions that you have commented. Okay, sorry for more questions from me. No problem, Vidya, that's why we are here. Okay, this is all that we want from you guys, to just learn and keep upskilling yourself. Okay, the situation right now we are in, things are going to be hard. Okay, so there will be less opportunities, that means more competition. Okay, need to help in projects. So there are projects, Naveen, if you have started Java, so there are 2 projects, or maybe some 2 games there. JavaScript, there is a game. If any one of you is interested in React, there is a course on React as well. Okay, for Java, if you want to start building or try to running or start coding in Java, if you have time, right? If you're in first year or second year, you can always go back there and start learning new things. Okay, if C++ is the most widely used language, we have a course on C++ as well. It's absolutely free, guys. And you will also get, if you join, if you have registered in the academy, you will also get some certifications regarding that. Okay, how do image processing and reading, sir? So image processing, I have no idea of image processing. Maybe I will just search you and I will tell you. Okay, guys. Okay, Vidya. Cool, guys. Thank you, Manish, Naveen, Abhishek. Thank you, guys. Thank you so much. OpenCV for image compare. Okay, Abhishek. I have yeah, I have no idea regarding this, Abhishek. So okay, build some project for final year. Okay, we will work on that. Yes, that can be done. Okay, Abhishek. Okay, thanks. Okay. Okay, thank you so much, guys. So I'm just concluding this session. Thank you, Afrin. Thank you, Vidya. Thank you so much, guys. Thanks a lot.